Hi all, it's Matt. This is going to be the second part of the functions video, the functions lesson. So this is going to pick up right where the other script left off. So if you have not watched that other video, please go and look at it now, because this is going to be a little confusing if you're not familiar with that video. So, and one other thing, apologies for the poor audio on that last video. My computer used the wrong mic, so hopefully this one's better. So we're going to pick up with our outlier function, and this is the function that we wrote. And then one thing we didn't cover is our tests weren't very comprehensive. So our outlier function, we tested it basically with this configuration, just a bunch of ones and a 100, and it returned the right value. It said the 100 is an outlier. We didn't test this case where the vector also contains an NA value. And so we kind of want to start with what do we think our function will return in this case. Remember, NA values are treated as unknowns in R, so this is saying what is the outlier of these numbers plus an unknown value. By the way, this is a good way to build your intuition with R by trying to figure out what code will do before you run it and then see if you're correct. So we'll go ahead and run this. And it's going to return an empty integer vector. Remember from the previous video, that means there were no elements in this vector met the criteria of an outlier. But that's weird because we expect that the 100 is an outlier. You might have guessed that this would return an NA value. But it didn't. It returned a blank. It said there are no outliers here. So we really want to figure out why. To do this, you need to do a simple debugging of your function. So the most simple way to debug a function is, especially a function that you own, you wrote, is you use a function called browser. So we're going to put browser right here at the first step of our function, and then we're going to redefine. So now if we look at outlier, it's got that call to browser in it. So what's going to happen when we run this line of code? A couple things. One, you'll notice that my prompt changed. It now says browse instead of the regular caret prompt. And you'll also notice here it says debug at number 4. So that means that we are now in the debugger in R. And if you write your own functions, knowing this is going to help you in so many ways. So for one, essentially we are inside this part of this code. We can do a bunch of things here. We can see what's in our environment. It says we have a single vector x. We can look at x. X is, that the input string or the input vector. So we can also do, if you do lowercase n, that's for next. And what that means is we're going to take the next step in this function. So you see it says debug at now number 5. If I do ls, I now have 2 things in my environment, and we can actually look at standard dev. That's an NA value. So this might be a little weird to us because we calculated the standard deviation. It included an NA. The NA basically propagated itself. We can also go over here and say, okay, well, that's clearly an error. We want to do NA remove equals true. Let's rerun that line of code. And we can see now that we have a real value for the standard deviation, not an NA. So what else is in our environment? Well, that's it at the moment. So we'll hit lowercase n. And it's run down now one more step. So we do ls again. We now have mn. So I can look at that. And again, it's an NA value. Well, shoot. We forgot to put over here in our function na.rm equals true as well. So we've got 2 bugs in our code. So we'll actually run this line of code, and now if we look at mn, the mean value, we see that we actually have a real value. So then, if we hit next one more time, we'll exit out of the function. Because if you look at here, the next thing that it will evaluate is the last argument to the function. So this actually might be what we want to do. We might just want to hit n, and we'll kick out of the function, and we'll see what the return value is with our modifications. So we'll do that, and now we, instead of an empty string, we say number 7, which is the 100. So we're good, right? We fixed our function. Well, so we'll save it, and then we'll send it back to the console to evaluate it with our modifications. And now let's run it again. Oh shoot, we left that browser call in there. So we don't really want to step through this function. We've got 2 ways to get out of this browser. One is capital Q quits out of the function from where you are, and it doesn't evaluate it. So if we do Q, we quit, we're back to our prompt, but the function didn't actually run. So we'll do this again. The other option is a lowercase c. So lowercase c says continue. And continue just means run the rest of the code, but I don't want to step through hitting n. So see, function actually ran, and now we're here. So we'll go back, we'll take this browser call out, and that is, we've just debugged our first function. This is incredibly useful. If you ever write a function and it's doing something weird, being able to put just a call to browser in allows you to step through the function and look around inside the function and see what's going on. Very, very powerful. The other thing you can do is maybe your function is only giving you the wrong results for one thing. You know, let's say maybe if x is larger than, well, we'll say if is integer of x, then browser. So maybe this is the case where the function is working correctly with real numbers, with numeric values, but if you give it integers, it's breaking. So now you can say, well, only let me look around in these conditions. Similarly, we could have gone, well, no, we don't want to put, one thing you don't want to do is you don't want to put browser here, because what it'll do is you're at the end of the function, and so it'll say, okay, here you are, and then it'll just return. So that's the one thing you need to be aware of. But anyway, there are lots of other debugging tricks. There's lots of other things you can do to figure out what's going on inside your function. But that is the easiest, and if there's one thing you need to know, it's that when you write functions. So the last 2 topics we want to touch on just briefly. So one of the problems with this function is it's not very robust, right? We saw that when we put in an NA value, it returned an empty vector. So one of the things that we can do with this function is we can make it more robust by adding checks. So we might say, for example, what happens to our outlier function if we put in accidentally a character vector? So outlier of letters. We'll run it. Oh shoot, I haven't, capital Q, I haven't redefined this function since I put browser in it. So there, we'll rerun it, redefine the function, and now we'll call it with letters. Remember, letters is just the lowercase letters. It's a constant in R. So if we run this, we get this error. I don't know about you, but this error is pretty confusing. There's a lot of confusing code in here. It's not really clear where this error is occurring. So we need to we could just leave this. We could say, well, our users will have this error. It might be better to put in a check where we say, okay, if is.character x. If x is a character, what do we want to do? We want to stop. We actually want to do an error, but this time we want to control the error. We want to say, provide a message that says, please provide so we'll just say, hey, the problem is you didn't provide either numeric or integer input. So here, we'll define this new version of the function, and now when we do outlier letters, you can see we still get an error, but now we have a more useful error message that says, hey, please provide numeric or integer inputs. This can be really helpful. Basically, you want to write your functions to guard against situations that might break them, or worse, might give the wrong result without any indication. So these checks, things like this, will help make your function more robust. And then again, the other way to make your function more robust is these cases. These should be added to your tests. So now we've got 4 tests. We've got a test with an NA, we've got a test with characters, we've got a test with no outlier, and we've got a test with an outlier. So you can see how this continuous testing, if we change this function, which we're going to do in a minute, we can rerun all of our tests and see if they still pass. Very powerful. So the next thing that we want to do is we actually want to, this now is hopefully a little bit more robust. It's not very flexible. So for example, what if we, instead of centering by the mean, so basically taking the difference of each value from the mean, what if we wanted the user to maybe be able to override this? We say, maybe it makes more sense to allow the user to put in just an average value for whatever he measured. It might be that the mean of your data isn't representative of the population mean. So you want to make it more flexible. So one way to do this is we lift this up and put it into the arguments of a function. So here we're going to say, actually, now there's 2 arguments. There's x and there's mn. Well, mn isn't very, it's not a good name because it doesn't tell you, we originally meant mean, but what if a user provides some other value? So instead we're going to change this argument to be center value. And the default argument for this is the mean of x. This might not be clear to you, but this will become clear. These default arguments allow the function to continue the same way that it did before. You have the default, nothing has changed, but now the function can be overridden, the default can be overridden. So we'll run this, and now we'll try our tests again. We got a new error. So let's look at this error. It's saying, okay, object mn not found. Well, how can mn not be found? Well, again, remember our debugger, our debugging strategy. We can put a browser call in here. We'll redefine it. We'll call it. And now we're inside the function. We can look around. So we see we've got 2 things. We've got x and center value. X there, center value that looks like the same mean that we calculated before. So what's the problem? Well, the problem, if you're sharp-eyed, is we didn't actually we changed the name up here in the arguments to be more sensible. We didn't change it down here in the function body. So this should actually be center value. So we're going to go over here. We're going to capital Q quit. We don't want to continue running. We'll pull out our browser call, or we can even just comment it out. We'll hit Control Enter to define it, and now we'll run our test, and our test passes. So we made a change to the function. We were able to we introduced a bug. We caught the bug, and now we can rerun our tests, and our tests are giving us the same thing. So the other thing we can do here, so we're going to copy this. We have a new test because we actually expanded the functionality of this. So we're going to say we want the center value to be 5. Oops. We'll run it. We get the same result. That's actually pretty good. We now have 5 tests, and we're now testing a new feature of our function. This is a very, very, very powerful way to write functions. Is basically you add tests as you find errors, or you add tests as you add features, and it works. So there's one more thing I want to talk to you about. So let's say we want to expand our outlier function. So we have this function. I'm going to copy it down. By the way, this isn't great workflow. I would normally have this function in a separate script. But so here's our outlier function. What if we want to make this even more flexible, where it has multiple different techniques for finding an outlier? So maybe we have an argument here that is like type equals, we'll call this one standard deviation. But what if we also wanted to allow a quantile method? You see this in a lot of functions where it allows you to switch behavior. So one thing we could do, we have this code here. We can say, well, if type equals quantile, or oops, this is standard dev, run this code, else, and then in here we'd put in something for the quantile. This might work, but it can quickly get out of hand. You can start making, you add more code. Maybe this code gets more difficult to understand. Like, this can get out of hand really fast. So the last topic I'm going to talk to you about is, we basically want our functions to be small. We want them to be easily tested, and we want them to be easy to maintain. So oftentimes we want functions to do just one thing, and then we'll combine functions in other ways. So here, this will make sense as I show you. So let's say instead of doing that, that's no good. And it's not bad, it's not ideal. So instead, what if we do this? We're going to say outlier. Outlier. We're going to create a new function. And we're actually going to copy our old function. So let's just copy all this. We'll put it in. So now we have a specialized function that just does the standard deviation. We'll do another function. And what did we call the other one? Quantile. And I won't use those dots. We haven't really explained what they do. Okay. So we have these two functions, and now our outlier can't type today. So we're going to do outlier is this function. Now I am going to use those dots. And actually we need a type in here. Where did I put this? You'll notice I'm struggling a little bit because I'm not using my typical setup. Okay, so now we've got a function here that is an overall function for outlier. And now it says if type equals standard deviation. Outlier standard. So here's what I'm going to do. Notice these three dots. These three dots are special in R functions. They're pronounced dot dot dot. It's not an ellipsis or anything else. It's dot dot dot. What dot 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 means is any additional arguments here that you don't know what to make sense of, pass down into here. Sorry, I'll finish this off so it makes full sense. So, sorry guys, we'll use an if else, outlier quantile, x dot dot dot. So this is now this is our function. These dot dot dots mean take whatever extra stuff you find here and pass it into this function. So remember our standard dev function had a second argument, which was center value. So using those dot dot dots, if I say outlier x type equals so here we have three arguments. Outlier, this function here, only has 2 plus the dot dot dot. What it does is it'll take this and it'll say, well, I don't recognize this, but I'm not even going to try to interpret it. I'm going to pass it along to outlier underscore standard dev. Just gets passed along. So the important thing is the dot 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 inside the function body says put the stuff here. The dot 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 in the argument says pull it from here. So if you find extra stuff here, collect it all up and then pass it right into here. And here, since we have an if else, it says pass it to either this function or that one. I know that's probably a lot. Again, I will post this video and some exercises to practice this, and I'll probably clean up this script a little bit. As always, if you have any questions, send us an email or stop by office hours. Thanks. Bye.